I hope everybody is fine at home. And the only thing that I will say that you have to maintain your own self-discipline, and that is going to help under these situation. With all that we will start today another topic, that is a fiber overlapping index. Now, fiber, that you remember that in last lecture that we talked about longitudinal behavior of the fiber. In longitudinal behavior of the fiber, two aspects that till date we have covered. One, this your spinning in coefficient, where that we measured the fiber extent, and fiber extent that we this explain that it is the length of the fiber in the yarn. Means once we see a fiber in a yarn, so that from one starting point to end point, what is the length of the yarn? That is the your fiber extent. And fiber extent divided by the actual length of the fiber, we define as a spinning in coefficient. And there that we said that yes, if a spinning coefficient is increasing, means fiber extent is increasing. And if a spinning coefficient is equal to 1, means fiber extent is equivalent to length of the actual fiber. So on that basis that we said, yes, this is one measure which indicates how fibers they are longitudinally placed in a yarn, and this measuring this spinning coefficient, that we are able to say that if value of spinning coefficient is increasing, then it is indicating my fiber orientation is improving, fibers are becoming more straight and parallel, and so that is accordingly going to help my mechanical properties of the yarn. So this is one aspect. Then second aspect that we talked about migration, fiber migration in the yarn. In fiber migration, this is again this longitudinal behavior, but in this case that we talked about to measure the position, radial position of the fiber from yarn axis. Because in a twisted yarn, fiber will always have a helical configuration. Due to twist, it will form a helical configuration. And now the moment that it is forming a helical configuration, so then definitely one has to see that, okay, how this fibers are radially placed from yarn axis. And because this radial position is going to talk how interlocking structure that I can have. The moment that I have more radial position of fiber from yarn axis, so it means that it is interlocking all layers underneath, and so that it is accordingly influence the property of yarn. So that is again another measure which we say that is a important parameter. And this we also discussed that your fiber migration will depend on type of fiber we are using, whether longer fiber, this finer fiber, or that I'm using say fiber of different modulus, rigidity, and they are going to influence my this fiber migration. And migration that we define, yes, the fibers, once that we are making a yarn, the fibers are under tension during a production process, and once that they reach to yarn stage, so that the fiber will try to come under a minimum energy state, so they change their position in the yarn. So ultimately, that the radial position will change, and accordingly, that we have this defined three parameters: that mean fiber position, root mean square deviation, and migration intensity. And on that basis, that we explain how that your yarn characteristics will change the moment my mean fiber position or root mean square deviation or migration intensity in changing. So these two important indexes that we talked about and that we have seen its importance. Now today that we will talk again under this umbrella of longitudinal behavior of fiber. Now we will talk another index, this fiber overlapping index. This particular topic that you will not find in literature, because this is a new concept that we have started one of my PhD student, that he started working on that, and that we realized that yes, this fiber overlapping index, it becomes another important index which explains the structure of fiber. Because there are certain things that I will talk today that we are not able to explain, because repeatedly that I'm talking. Yes, you may find a fiber have a good fiber extent or high fiber extent. You may find a fiber that have a higher packing density. But even though that the strength of the yarn is not good, the strength of the yarn is less. Why? That we were all the time raising this question, and today that we will try to answer, because by this time now that we have very good information about yarn structure, so that we will be in good position to explain these type of shoes. So now first let's understand on what I mean by this fiber overlapping index. Now see that this figure, this is my say one fiber in a yarn. Because as you see, in a yarn, the fibers that they are placed longitudinally, so they are overlapping each other, because there's a number of layers are there. So then definitely that they will find this, suppose if I say this is my fiber and this is another second fiber, which is moving like this. So what you are noticing that what is the overlap between this fiber number 1 and fiber number 2? So this is my overlapping length. Otherwise, the fiber is going up to this point, and second fiber that is moving this way, and it is going up to this point, say. So that I will call, suppose this is the length in the yarn, that is my fiber extent, because this is starting point of the fiber in the yarn, and this is the end point of the fiber of the yarn. So this is my fiber extent. Yes, in case of second fiber, my fiber extent is this point, the starting point to end point. But overlap length is this portion. This is my overlap length. Same way that you talk about, say, this fiber 3, it has this different configuration. So it is moving like this. So now that you'll find that this overlap length that between this fiber 1, 2, and 3 with respect to fiber 3, this is now this overlap length. Like that, I have a fiber 4. So this is a different configuration it is taking. So that this overlap length of this particular fiber with respect to fiber 1, 2, 3 is this length. So like that, I can go on. I can go to say n number of fiber which you have in a yarn. So now what is indicating that yes, beside this fiber extent, that this another important issue is that how this fiber that they are overlapped, and what is my overlap this length. So now first that we will try to understand how to measure these indices on all, and then we will talk its significance, and then we will try to talk about different properties, different situation, that how that my packing density is changing, or fiber, the spinning unit coefficient is changing, and why that I'm not able to explain certain parameters. So the moment that we understand fiber overlap to large extent, that we are able to explain these type of issues, which a number of times that I've raised during these lectures. So now that you see, let's understand first how we can measure first. So it is again, we will use this tracer fiber technique, which we have already talked, so that my fibers, so they are visible to me, and I can very well measure the your fiber extent. So what we are saying, fiber overlap index is that for more than 2 fibers simultaneously overlapping. So I have n number of fibers. So I will talk about 2 indexes. One that we are measuring only this adjacent 2 fibers, and under this the index that we will talk about, where that we are considering n number of fibers in the yarn. So this approach that we will talk about. So let's first talk that you see this as we say that start adding the total length as soon as first 2 fibers start overlapping. So now what we are adding this length. Now fiber 1 and this is my fiber 2. So this is the length that we found in this two adjacent fiber 1 and 2. This is the length. So this is my overall overlapping length. So the same thing that we say, start adding total length as soon as first two fiber start overlapping. Then consider your area of overlapping up to which the first fiber which is overlap and terminates. Then put the value of L1 to Ln in the formula that I will talk about Fy. So that how that we are measuring here, that this is the way that we say L2 is a simultaneous fiber overlapping length for first two fiber F1, F2. L3 is a simultaneous fiber overlapping length first three fiber F1, F2, and F3. Ln is the simultaneous fiber length of first n fiber F1, F2, F3 to say Fn. So now you see that what is my first two fiber overlapping length, that is for a simultaneous fiber overlapping say I is equal to 1. So total overlapping length first two fiber is 2 into L2. You just go back here. This is the length. So that we are saying that between first fiber and second fiber. So that we were talking, and here that we say this total fiber overlapping by first two fibers. 2 into L2, same way we say total fiber overlapping by first three fibers. What are these first fibers we are referring? Fiber 1, 2, and this fiber 3. And that this length, how that we are measuring? And this is your 2 L2 minus L3 plus L3 into 3. What three fibers are there? So that ultimately I will simplify it. So it will become 2L2 plus L3. Same way, the total overlapping by first say four fibers. So that is 2 into L2 minus L3, L3 minus L4 multiplied with 3, and this multiplied with 4 into L4, because that we are talking in four number of fibers. So by simplification, I'm getting 2L2 plus L3 plus L4. So like this, that we can say this total fiber overlapping length by first n fiber. So that we are defining 2 into L2 minus L3, L3 minus L4, L4 minus L5. Like that we can say Ln minus 1. This plus n, now total number of fiber into Ln. Ln is this say last fiber. So this we will simplify. We will get this L2 plus L3 plus Ln L4, and that is your Ln. So now that we say we can calculate this your total fiber length estimated. That is your n into average fiber extent. What is my fiber extent? We have already defined in individual case for say first fiber, my fiber extent is this much. Then for the second fiber, which is moving here, so fiber extent, that the starting point of the fiber and point equal to 1 to n Li whole divided by n. N is number of fiber whole multiplied with average fiber extent. Average fiber extent, how that we will calculate? Now that we have for this fiber extent, for second fiber, this is my fiber extent, third fiber, this my fiber extent. So then I can calculate this average fiber extent, what we have already talked in case of spinning coefficient. So now that we say this is one index that we are getting. So Fy can range from 0 to 1 for a number of overlapping to total well state and parallel fibers overlap. That is ideal case. If ideal situation that I have, so that you may get this overlapping is equal to 1. It means one fiber is just over this other. So what is indicating that as my overlapping strength is increasing, then definitely yarn this will contribute better to this say your mechanical properties of the yarn. Imagine, suppose that I have two fibers. In one fiber, that my overlapping length is say my total length of the fiber is say 38 actual length, and overlapping of 38 that you say it is say 23 mm. Another situation, I have fiber, again same length of the fiber I'm using, but my overlap length is 28. So from 23 to 28, and this yarn that I'm twisting it, I'm giving the same amount of twist. But in one case, my overlapping length is 23 mm, another case 28 mm. Assuming that my fiber extent in both the yarn is same, or both the fiber is same. Okay, so now you tell me that which yarn will contribute more to yarn strength. That yarn with the average say overlapping length 28 or 23, which will contribute more? Anybody? Hello? You got the question? Good, this is important because on that basis, now I'm going to explain this certain your case studies. So you should be very clear. Say this overlap length in one case is 23 mm, another case is say 28 mm, and the fiber extent in both the cases same. Twist and everything is same. So under you can say the packing density is also same, but overlapping length is different. In one case is 23 mm, another case is 28 mm. And now I'm measuring the say tensile strength of the yarn. Which yarn will have this higher strength? Anybody can answer? Hello?
So 28 mm overlapping yarn.
That will give you more tensile strength. Now I have put a different question. Yes, you said that the overlapping with the higher overlapping will give you more strength. Now same situation, we say, suppose that my overlap length is one case is 23, another case is 28. Now in case of say 23 mm, I give more this in part more twist. Packing density is more, but overlap length is lesser. Still that because I have increased the packing density of the yarn, my strength will increase or not? Overlap length is less, but packing density is more. What is going to happen?
It should increase.
Pardon?
As packing density is increasing.
Packing density is increasing. So on overlap length is lesser.
But sir, interfiber friction will more in if packing density is more.
No, I've given you the situation. Packing density is more. In one case, say packing density is 0.45. Another case is packing density is 0.5. But this overlap length remains same, 23 mm. Now, which yarn will contribute more to mechanical properties? Okay, this now I'm going to answer with this a case study, and where that we will be able to answer these issues. Now here that you see what we have done, that we have measured this fiber orientation, this in your ring yarn, rotor yarn, and air jet yarn. For time being that you forgot type 1 and type 2. This is the two different ways that the ring yarn is being produced. So that I will only address ring yarn type 1, rotor, and air jet. Okay. Here that I've used same fiber and same count and every twist, everything is same. But yarn is made on two different technologies. That is ring, rotor, and air jet. And then we measure fiber extent. Then this fiber, this your FPO, that is the your overlapping between two fibers. Only just we are considering two adjacent fibers. And FOI, that we are taking into consideration all fibers in the yarn. So there are two ways, that only simply two adjacent fiber that you take it, and this your total number of fiber. But we found with our practice, definitely FOI, that it gives a better this correlation with mechanical properties in comparison to FPO. So that we wanted to just measure that which index is better. So that was the idea, that we have taken into consideration both. So FOI, that is fiber orientation index, overlapping index. This is now my total, this your this extent, this your trailing hooks. So extent of trailing hooks. This is the your number of trailing hooks. This is the extent of leading hook. That is your number of leading hooks. And this is my average this extent, hook extent, and this is the total hooks number. So that it means that we have measured this trailing hooks and leading hook. We wanted to see that technology-wise, because the fiber extent will depend on that, and total number of hooks. So these are the things that we have measured in all three yarns: ring yarn, rotor yarn, and air jet yarn. Now see this fiber extent. Fiber extent in case of ring yarn is 28.2. In rotor yarn, it is 19.89. And in case of air jet yarn, this is 24.64. Okay. So now that if we see this fiber extent point of view, that we are noticing that yes, ring yarn is giving me higher fiber extent, followed by air jet yarn and then rotor yarn. Rotor yarn is giving the least. And there that this once that we were talking about spinning coefficient, so we explained that why, what are the reasons that once that we are talking about different technologies, why that fiber extent is going to be different, because there are a number of reasons that we explained in case of rotor yarn, that why that fiber extent will reduce, because that we have seen how fiber is moving from transport tube and getting deposited on rotor, and once that it is getting deposited, how that peeling off is taking place. So then both the situation, once it is getting deposited on rotor and it is in transport tube, some disorientation is taking place. At the same time, once that we are peeling off the fibers, so depending on the fiber position with respect to transport tube and rotor, that your hook generation is taking place, particularly leading hook, and that is responsible to reduce my fiber extent, this part that we have already talked, one that we talk about spinning coefficient. That same way that we talk about the air jet, in air jet yarn, what you know that you are dividing this your fiber ribbon into two parts after roller drafting, and the one part is becoming core, another part is becoming say sheet fiber, so that once you are imparting the twist, so sheet fibers are getting wrapped over the core, but in the process the core fibers are getting untwisted. So it means that the majority of fibers are in the core, which is normally 70%, and 30% is your rubber fiber. This in general, of course, this may vary, but normally that you will find this is the ratio that is being kept between core versus your surface. So now that it means that 70% fibers that you say that they are not or less twisted, so they are more straight and parallel, and that is the reason that you see that air jet yarn is likely to give this more fiber extent. So now that I know my fiber extent, now I know my FY. FY in case of this ring yarn is 0.49. In case of rotor yarn is 0.36. In case of air jet yarn is 0.42. So one way that from this table, this set of experiments, that what we are saying that yes, your ring yarn is giving the higher FY, followed by this your air jet yarn and rotor yarn. Rotor is again giving the least. So what does it indicate? The moment we say 0.49 FY index, it means that 50% of fiber length is overlapping of this, and here that you can say only 42%, and in this case is only 36% of fiber length is overlapping. And now that the moment that we say overlapping index, and then we correlate with your fiber extent, so that we can say the fiber extent and FY has a good correlation. Higher the fiber extent, more is the this FY. Here that you see, here the out of these three yarns, rotor yarn is giving the least your fiber extent. So simultaneously that we are also getting at least FY. If we talk about this FPO, that is again, it is giving the same. You get this highest value of FPO in case of ring yarn, followed by air jet yarn and rotor yarn. But here that you see that once that we say FPO, only my issue with FPO is sometimes that I may be biased towards selecting two adjacent fiber. So that might give us sometimes this wrong values. But the moment that I'm talking considering all fibers in the yarn, then definitely that will give you a better picture. So that's why that we found that yes, FOI is a better way to this explain or define this overlapping rather this FPU. FPU of course give a sufficient good idea, but in comparison to FY, then definitely FY is giving better result. Now that you see this, we have understood the overlapping index, and now that we raised the certain issues. Take a typical case. I will give you two examples, and where that I will talk and try to correlate my fiber extent, packing coefficient, and overlapping another thing, and I will try to explain. Now, take a typical case in case of ring spinning yarn. Suppose that I make a yarn, and please listen carefully so that you have to give the answer. In one yarn that I have made at your 15,000 spindle RPM, my other parameters, everything is same. Same yarn that I made it on, say 20,000 spindle speed. So 15,000 RPM to 20,000. My fiber parameters, yarn linear density, twist, and everything is same. Two yarns. Which yarn will have higher packing density? Yarn with the 15,000 spindle speed and yarn with the 20,000. Which yarn will have higher packing density? How spindle speed is going to influence my packing density? That we have to see. And why packing density will change? That I have to understand my spring tension. So in spring tension, in which case will be higher? 20,000 RPM or 15,000 RPM?
20,000.
20,000. This RPM will give you higher spring tension. Okay. So higher spring tension will give you more packing density or less packing density? What spring tension will do? Anybody? Very rightly you said that yes, spring tension in case of 20,000 RPM will be higher than 15,000 RPM. Spring tension will align the fibers. It will bring this fiber closer.
Packing density will be high for.
Pardon?
Packing density is higher for.
Packing density with 20,000 will be higher. Okay? Fine. Everybody is agreeing? Or anybody has still doubts? Okay, if we take this statement, yes, the packing density with higher spindle speed will be more in comparison to lower speed, lower spindle speed. Fine. Now that you measure the yarn strength, in which case that you find that yarn strength is more with 15,000 spindle speed or 20,000 spindle speed?
20,000 because the packing density is higher.
Packing density is higher, so that you say that the strength should be more.
Yes, sir.
Everybody is agreeing with him? Or you want to change the statement? No, you see, if you say this statement that because the higher spindle speed, we said the packing density is higher, and that's why that yarn strength is more, then I will raise another issue. If it is so, always that we should go for higher spindle speed, and why that we try to optimize spindle speed? Higher spindle speed will give you more production. Because packing density is more, strength is more, so the breakages should be lesser. Yarn breakages. So then why I should go? I should go for a higher spindle speed, maybe even 20,000, 22,000, 20,000, 22,000 will give me further higher packing density. Or according to your statement, strength should be more. Are you able to understand what I'm trying to say?
Yes, sir.
Your statement is that yes, higher spindle speed, higher spring tension, higher packing density, and packing density is more than. That's why that you are saying that strength should be more. That is your this issue in your mind. I'm correct.
Yes, sir.
And now here this is the issue. Means yes, normally that we say yes, higher the packing density should give me higher strength. But at the same time that I will bring to your notice, the moment that you are increasing your spindle speed, fiber alignment is taking place, fiber have more tension and all, and the fiber try to become closer. At the same time, fiber straightening is also taking place. So fiber extend will also be more with higher spindle speed. So fiber extend is more, means the spinning coefficient is more. Packing density you said is more, but practically that you'll find higher spindle speed gives you the lower strength. This is a fact. So higher spindle speed is giving me lower strength, but higher spindle speed is giving me higher packing density and higher this is spinning in coefficient in comparison to lower spindle speed. Now then how I will explain this phenomena, and this is a fact, already established fact. Yes, the moment otherwise, as I said, if a higher spindle speed giving me this higher strength, so I will go on increasing my spindle speed because 22,000 will further increase my packing density and this is spinning in coefficient. And so strength, if strength is more, then why? Who is stopping me not to go for 22,000? Because 22,000 RPM will give me higher production, which I want. Economically, it is better. But the reason is why that I'm not able to increase my spindle speed, because this higher spindle speed give me lower strength. So now it means packing density and this spinning coefficient is not supporting. I will give you another example and then I will answer that point. That's why it is so. Take a rotary spinning system. A rotary spinning system, again that I'm making this, say 2 yarns, one at 1 lakh rotor RPM and another is say 1,20,000 rotor RPM. My rotor diameter, count, everything, all parameters are same. So higher rotor speed will increase my packing density. Because what is happening? Why that I say so? The moment that you are increasing this your rotor speed, the centrifugal force will increase. Higher the rotor RPM, more centrifugal force. And this centrifugal force will press the fiber in rotor this groove. So it will press the fiber downward towards this rotor groove. So that my before twisting yarn, the fibers are becoming more compact. And if they are becoming more compact, it will give me higher packing density. And it is established, higher rotor speed will give you higher packing density. Of course, up to certain limit. After that, packing density will not increase once you will go very high rotor speed. But it is again established fact, higher rotor speed give me lower strength. Otherwise, the same thing is applicable here. I will go on increasing rotor speed if my strength is increasing. So now with both the situation that I'm finding that yes, even my packing density is increasing, spinning coefficient is increasing, my strength of the yarn is reducing. So keeping now today's topic in mind, overlapping, now try to answer. Keeping this information today, what I have given you, this overlap index. Now tell me that in which case overlapping will be lower. Your 15,000 spindle RPM versus 20,000 RPM, or 1 lakh rotor RPM versus 1,20,000 rotor RPM. In which case this overlap, or do you think that overlap length will change if I'm increasing the spindle speed or I'm increasing the rotor speed, or it should remain same? My question is clear? Because ultimately, I have to answer that point. That why higher spindle speed? My strength is reducing, but yes, packing density is increasing. Spinning coefficient is increasing. So there is something else in this texture which has happened, and which is responsible for a reduction in yarn strength with a higher, say, spindle speed or higher rotor speed. Can you just imagine for time being that what is going to happen? Just think of the, how that, do you think that if I'm increasing my spindle speed, do you think there is going to be some change in fiber overlapping or not? Or fiber overlapping will remain same? It is not going to affect or getting influenced by spindle speed or rotor speed. Anybody can answer? You see that what is going to happen? Again, come and explain on the basis of, say, spinning tension. In case of ring spinning, what happened? Fibers you are drafting, roller drafting, and that the ribbon is coming out from this front roller nip, and then this yarn is getting twisted. As I said that I'm increasing spindle speed, so by spinning tension, the yarn and the yarn balloon will increase. Now, once that spring tension is increasing, fibers are nipped at front roller nip, and my spring tension is increasing. There is going to be slipping between the fibers. And the once fiber bundle is there, which is coming out from the front roller, and due to spring tension, that the fiber slip is going to take place. So it means whatever over length between fiber I had during drafting, now after twisting, that due to slip, it will change. So overlapping is going to reduce as that I'm increasing my spindle speed. Same thing that we can talk in case of a rotor spinning system. In rotor spinning system, what happened? Again, that this once the fibers they reach to the rotor surface, so that rotor is rotating with a certain speed RPM. Centrifugal force press the ribbon fiber on rotor group. But at the same time, yarn peeling takes place. So this your yarn length, which we can say is also sort of a balloon length. Yarn is now getting pulled upward, which is going to decide my spring tension. So the moment I have higher rotor speed, my spring tension will increase. So upward force is increasing, but other side that a centrifugal force is pressing the fiber ribbon downward. So now two forces are acting in opposite direction. Spinning tension is this acting in upward direction, and centrifugal force is acting in downward direction. As my this rotor RPM will increase, so my centrifugal force will increase. Correspondingly, my your spinning tension will increase, so upward force is also increasing. So now imagine that you are peeling off the fiber, and these two forces are acting in opposite direction. One is trying to pull the fiber, another is trying to extend the fiber. What is going to happen? My fiber will slip at that point. And this imagine that point has a least twist. The same thing in case of ring spinning, that at nip point that you have a least twist. So it means the chances of fiber slippages are going to be more at that point. And due to these slippages of fiber, and that slippages of fiber is going to decide my overlap. So overlapping is going to reduce. So as I explained, that movement that I have a yarn with lesser overlapping, even though that there's this nicely pegged and highly pegged, will reduce my yarn strength. So the answer is yes. The moment that I say I have increased my spindle speed, and another case that I made a yarn with the 20,000 spindle RPM, my packing density will increase. Your spinning coefficient is likely to increase, but strength is reducing. So why it is reducing? Because due to higher spindle speed, fiber slip will take place because from the nip point where that I have a least twist. So overlapping length will reduce. So ultimately, overlapping length is going to decide my your yarn characteristics, and on that basis that will say that if suppose my over length is reducing, so then we can say that is the reason that with a higher spindle speed my yarn strength is also reducing. Same way in case of rotor, high rotor speed, that once we measure this your overlapping, then if overlapping is going to reduce, even though it is nicely packed, that my strength is reducing, so that we can say that overlapping will be the reason. So now that this index again becomes very important. Of course, as I said, that very less work is being done in this area, and that has to be exploited because it is a good measure which is going to again define the orientation of the fiber. So it means now that what we say, in the longitudinal behavior, this is one another index that we have to introduce, and we should measure the overlap index, FY, fiber orientation overlap index. So there, that the fiber overlap index is now again explaining this structure in better way. There are certain things which we were not able to answer. The moment that I have a good knowledge about FOI, so I will be in good position to answer certain points. Otherwise, it start some sort of a confusion. Yes, packing density is increasing, spinning coefficient is increasing, but even though my strength of the yarn is reducing. So here that what we can say at this stage, that once that I'm defining these mechanical properties of the yarn, I should not consider only one index, one structural index. I should see the yarn structure in totality, all these structural characteristics, and this the moment that I understand all these things, then I will be in good position to give the this better explanation, better reason why that it is happening, why this change is bringing this change in my this yarn property. So that's why that we got a number of cases that we found. But yes, again, you should be very, very clear at that point. And don't say that yes, packing density has no role. Yes, packing density is increasing. Packing density will play a role. Spinning coefficient will play a role. But beside that, some other changes in the structure are taking. Ultimately, they are dominating over other packing density, spinning coefficient, other factor. It is not that you say that packing density will not contribute to yarn strength, or spinning coefficient will not contribute to yarn strength. Yes, they will contribute to yarn strength positively. But as we say, other factor now which now we are addressing, say FOI, is now dominating over other parameters. And so that influence of FOI is now more significant in comparison to, say, packing density and spinning coefficient, the case that we have addressed, this ring spinning and rotor spinning. So message is clear, or any doubt? Anybody has any doubt here?
Yes.
Hmm?
No doubt, sir.
It is clear now.
Yes, sir.
So now that you see this, moreover that I have touched this structure, because I have now limited lectures. So now I will just converge to mechanical properties, and this background that what we got till today about yarn structure, and then we will try to explain this your tensile properties of the yarn, this yarn failure, why fiber will break, why yarn strength will be lesser. So keep with this background in mind. So tomorrow that I will talk about these issues, that how my properties of the yarn are going to be influenced by this structure. So because all the time that I say that if you will find the literature will say that yes, spindle speed will decide my yarn strength. But I will always say spindle speed will change the yarn structure, fiber orientation, and this fiber orientation will change the strength. So this your machine parameters are responsible to change the orientation of fiber in the yarn, and this orientation of the fiber is responsible for. So you have to always explain this why that a particular machine parameters, how that this machine parameters is going to change my structure of the yarn, and the structure of the yarn ultimately how that it is going to influence yarn properties. So this I will now take this tomorrow. Now another important issue that what I talked yesterday with the one group this during tutorial, we have to conduct one this exam on our tutorials, good tutorial that we have talked, discussed and all, and we have to decide the date. So yesterday that people that they were saying that Saturday. So Saturday is okay with you? This coming Saturday.
Yes, sir.
So now tell me the timing. What time? I'm leaving to you. It will be 1 hour. So tell me what time. Forenoon, afternoon? And forenoon what time? Afternoon what time? Or should I decide?
So in the evening, yes.
Pardon? Repeat it again.
Will be
No, your voice is not clear.
He is saying in the evening.
in the evening. In the evening.
So can we put it 3 to 4?
Yes.
3 to 4 on Saturday, coming Saturday. It is okay? Or anybody has any reservation? Because why that I'm doing that, because few students they approach me because they are moving towards their residence, because the institute has asked because due to this situation in Delhi situation is becoming day by day worse. So they have been asked if they want to go to their residence. So few students might be traveling. So that is the reason that I'm pushing to Saturday. Otherwise, I was thinking on Wednesday. So I want that, yes, nobody should get affected due to this movement and other thing. So Saturday, can we now? This is this is final 3 to 4 on coming Saturday. Okay. So what I will do that I will send a mail. This Saturday, this 3 to 4 will be, and here that will be majority cases that will be your numerical based. Whatever that numericals that we have taken during these tutorials, and